A metal airplane is made in three major assemblies: the fuselage, the tail surfaces, and the wings. If we look under the aluminum skin, we can see that each major assembly is made up of many small parts and assemblies. In a factory, these parts are made in the sheet metal department. Sheet metal jobs require more floor space and man-hours than any other one department. Aircraft sheet metal construction generally consists of two main steps: fabrication of the parts, that is, making them, and assembly of the parts, or putting them together. To make a part, usually the flat sheet metal is first cut roughly to size. Shearing is one method and is most simply illustrated by hand snips. For large work, a square power shear is used, which also works like a pair of scissors. Another shearing machine, called the high-speed shear, or jitterbug, is used to follow curved lines and trim formed parts. One blade moves rapidly up and down, making a series of short cuts. Another tool used for similar work is the rotary shear. The cutting is done by two small revolving circular blades. A second method of cutting is called blanking. Blanking differs from shearing in that the cut is made by the quick punch of a die. In blanking on a punch press, the material is placed over one die and is cut out in a single stroke by a matching die attached to the plunger. The blanking method is also used for rough cutting thick parts on a machine called the nibbler. This machine cuts by punching out a series of overlapping holes. Sawing is another common way to cut metal. A bandsaw can be used for cutting straight lines or curves. For cutting heavy stock, the circular table saw is often used. Still another method of cutting is called routing. In routing, the cut is made by the sharp, fluted edge of a bit revolving at very high speed. The bit and motor are usually mounted on a free-swinging arm. To guide the bit, a pattern called a router block is placed over the metal. The bit is guided around the contour of the pattern by the operator. With this method, several identical sheets can be cut at one time. Although there are many other sheet metal cutting tools, they all cut by shearing, blanking, sawing, or routing. After the metal is cut, it must be formed or bent to shape. Originally, all these shapes were flat pieces. To form straight-line bends, a machine called the press brake is often used. The material is forced into a die on the bed of the machine and bent to the die shape. A series of bends like this is called the corrugation. A fast method of forming long, narrow parts is by using the power rolls. The material is fed through progressive dies. On the draw bench, long, narrow parts such as angles can be made. And if the angles and channels need to be bent, this may be done on a wrap forming machine. Machines called rolls are used to form parts with single curvatures, such as this section of a leading edge for a wing. But parts with compound curvatures must be made some other way. These parts were formed on a stretch press. On this machine, a die is pushed up against the metal sheet and stretches it to the required shape. Compound curvatures can also be formed on the drop hammer. The metal is shaped as the punch drops, forcing the metal into the die. Still another machine for forming compound curvatures is called the hydropress. The material is placed over a die on the bed of the machine. A rubber pad attached to the ram presses the material into or around the die. Using this method, many differently shaped parts can be formed in one operation. But regardless of the machine employed, sheet metal can only be formed by bending, stretching, or shrinking, or by any combination of these three. When the parts are cut and formed, they're ready for the assembly line. For most assembly work, jigs are used. A jig is a special device or fixture for holding parts accurately in place while they're being fitted together. Accurate fit is important because each assembly must, in turn, match up with other assemblies. After the parts are located securely in the jig, they are ready to be fastened together, in this case by riveting. Any rivet holes not already in the parts can now be drilled. In riveting, a straight shank with a head on one end is passed through a hole in two or more parts. Another head is then formed to hold the parts firmly together. Riveting is generally a two-man job. One worker operates the pneumatic gun, which drives the rivet against a bucking bar held by the other worker. Rivets can also be driven by pneumatic power squeezers of various kinds. With pneumatic squeezers, one worker can perform the complete operation. When you can't get a bucking bar to the shank end of the rivet, you may have to use one of several types of blind or self-bucking rivets. With one type, a special gun pulls the stem back into the rivet, forming an upset head. Another type of blind rivet is hollow and threaded on the inside. When a special driver is screwed into the rivet threads and pulled, the rivet spreads and bulges, like this, to hold the two pieces of metal together. Spot welding is another method of fastening or joining parts that is especially desirable where streamlining is important. In spot welding, two pieces of metal are held under pressure between two electrodes through which a large current of electricity is passed. The resistance of the metal causes extreme heat, and the two pieces of metal are melted and fused together at the point of contact. By means of these fastening methods, small assemblies are joined to each other to build up increasingly larger ones until the major assemblies are completed. Here we see the wing, one major assembly, being joined to the fuselage, which has also been assembled from many smaller units. Remember that underneath the streamlined exterior of the modern airplane is an intricate framework of sheet metal parts which have had to be cut, formed, and assembled to exacting standards of accuracy and craftsmanship.